Alright, we've done vectors in 2 dimensions, and we talked a little bit about it yesterday. We're going to do vectors in 3 dimensions today and kind of cover multiple sections that we've done. There isn't a lot of difference between what we've done in 3 dimensions, so just kind of a little bit of review with a little bit added to it. So if we wanted to know the vector between 1, 2, negative 1, and q, which is 3, negative 1, and 2. Okay, so I wanted the vector of P to Q. P is the initial point, and Q is the terminal point. We figured out the exact same way we did the 2-dimensional one. So what is it that we did in the 2-dimensional finding of a vector? Okay, subtracted the terminal point positions from the initial point positions. So 3 minus 1, that's the first one. Negative 1 minus 2, and 2 minus a negative 1. So that gives us 2, negative 3, and 3. That would be the vector in 3 dimensions. Pretty simple. Got it? Okay. All right, and then we also did something when we were given an initial point. Now this is number 8. What's the terminal point? So B, this vector is 0, 0, 1. And the initial point started at 0, 1, negative 1. We want to know what Q is. Okay? So how do we find the terminal point? And we do it the exact same way we did the 2 dimensions. What do we need to do? Yeah, we add. So we're going. Here's the vector that we got from P to Q. So we can find the terminal point by adding the vector positions to the starting point. So Q is going to be 0 plus 0, 0 plus 1, and 1 plus negative 1. So that's 0, 1, and 0. And that would, whoops, these are this is a coordinate. So make sure we got the coordinate down here. So the terminal point would be 0, 1, 0. So you add your vector to your initial point to get to your terminal point. If you want to know what the vector is, you have to subtract to find the distance from your terminal point to your initial point. Does that make sense? We've already gone through this. We did both of these in the first section. It was also on your quiz. Now we're just making it in 3 dimensions. Easy? Good enough? You understand? We'll do some problems here in a little bit. All right, let's just make sure. You guys do number 10. Number 10, the vector is at 23, negative 5, and 12. The initial point is at negative 6, 4, and 2. I want to know what Q is. What is the coordinate? Make sure it's a coordinate. I want to know the terminal point. So we add to find the coordinate. Okay, so 23 and negative 6 is 17. Again, it's a coordinate. Make sure you use the right brackets. 4 and negative 5 is 1, and 2 and 12 is 14. We got that right. Negative 1? Did I do it wrong? Yeah, thank you. Negative 4 and negative 5 is negative 1. Good job. Okay, now we also did something called magnitude. All right, so how do you find magnitude? What did you do to find the magnitude? Yeah, you squared each of the entries of your vector, and you added them together, and then you took the square root. So, just as a review, let's do 3 dimensions. Here's a vector 5, 0, and negative 12. So we're going to take the square root of the squares of these added together. So 5 squared plus 0 squared plus negative 12 squared. Can we figure that out, please? Braxton, what's 5 squared?
24.
What's negative 12 squared? What's 25 and 144?
169.
Yeah, the square root of 169.
15.
Good. So the magnitude of that is 13. Alright, now you guys all do this one. This is number 14. We'll do 1, negative 6, and 2 radical 2. Does the vector tell me what you get in reduced radical form, if you need to, for that magnitude? Did you see Liam anywhere out there? Good. Riley, what'd you get?
Probably finish it.
Okay. Anybody done? What'd you get?
Radical 45.
It's, no, that's right, but simplify it. It's not. No. One squared is 1, negative 6 squared is 36. 2 squared is 4. And radical 2 squared is just 2. 4 times 2 is 8. 37 and 8 is 45. That's the same thing as 9 times 5, or 3 radical 5. Okay. And again, when we get to the test, it's okay if you want to give me the decimal for that. You guys are going to use your calculators to figure some things out. Okay, great. Let's go on. So far, so good. Not too difficult. There isn't anything new. We're just adding another number to it, making it 3 dimensions. Tomorrow, you guys said nothing the other day about the fact that you've not been taught how to graph in 3 dimensions. Why not? Yeah.
We haven't been taught how to graph in 3 dimensions.
Oh, thank you. All right. So tomorrow, just for the fun of it and a nice easy grade for you for participation, we'll put it into the homework grade and not have any homework for the weekend. We're going to just spend the day trying to learn how to graph in 3 dimensions. Okay? Because you need to be able to do that. Or we can do section 5.
No.
No.
Does graphing sound fun?
I think graphing sounds amazing.
Sounds better than
Better than. Okay, all right.
Probably graphing and a little bit of pig.
Okay, so let's just make sure we can do some simple little calculations. Let's do. We're going to do 3u minus 1/2 v. So this should look familiar to everybody? Yes or no? Okay, so let's just say u, this is number 16, u is 0, 1, negative 3, and v is 4, 2, 0. Again, nothing's changed. Same thing you've already been taught how to do. Chapter 9 so far isn't very difficult. It's not necessarily easy, but it's not chapter 7. So everybody work this out. Some of you struggled with this. We're going to take a look at your quiz here in just a little bit. Let you guys see what you did. Done? What is subtraction?
zero.
That's a zero.
Picture of what that's showing here.
Let me see, where was this at? Oh, right now?
Yeah,
Where's it
like
at?
today's one.
Blow it up, where you?
There's another, I think it's a zero.
That's a zero. There, both numbers. Yes. Okay, so first thing is take 3 times the u, 3 times each entry. So 3u is going to be 0, 3, negative 9. And then we're going to subtract, you got to take 1/2 times v. 1/2 times v is 2, 1, 0. Now you subtract those. So 0 minus 2 is negative 2. So this is 3u minus 1/2 v. Negative 2. 3 minus 1 is 2. And negative 9 minus 0 is negative 9. Alright, we got it right. Here. Okay. Why can't you do that on the quiz when I give it to you? Okay, component form. If I said write this in component form, what is it that I'm asking for?
I and J.
In this case, I, J, and K. K is the third dimension one. So how would I write that then? You guys don't remember using I and J when we did the 2 dimensions?
Plus 2J minus
What?
9K.
Say it again.
Negative 2I plus 2J minus 9K.
That's it. Jog your memory. Okay, I'm not going to do an example. Let's just, you're just putting the vectors with the letters, okay? Right, in expression form. You also learned something called the dot product with 2 dimensions. How did we do the dot product in 2 dimensions? Yeah, some of you need to look because you didn't do well on the quiz. Huh? Yep, you multiply the same entries together and then you add those answers together. And in 3 dimensions, you just have 3 of the entries. So this is number 26. Oops. 26. U is negative 3, 0, 4. V is 2, 4, 1/2. So if we do the dot product, multiply the entries. Negative 3 times 2 is negative 6. And you add. 0 times 4 is 0. And add the next multiplication entry. 4 times 1/2 is 2. So the dot product is a value. Your magnitude is a value. When you're doing just operations like this, you're going to get a vector. So dot product gives me a value, this one, negative 4. Okay? Shouldn't have to do a lot of examples because you've already done this. Okay. How do you know if 2-dimensional vectors are orthogonal? If what's equal to 0? The dot product. If the dot product is 0. It's the same thing here. If the dot product is 0 in 3 dimension, then it's also orthogonal. Yes. Yes. Yeah.
What was it on the quiz? What was it? Yes or no?
It was not orthogonal. It was a good guess. Okay, almost done. Now let's do some angles between vectors. The angle between vectors. Okay, so your formula for the angle between vectors was cosine of theta equals the dot product of u and v and the magnitude of u times the magnitude of v. That was the formula, and it's the same formula here, you just have 3 numbers to deal with. So we'll do number 34. Here's your vector u, 4, 0, 2. vector v is 2, negative 1, 0. Many of you gave me the formula, but then wrote something that didn't even look like the formula, so I didn't give you any credit. If you started out doing it correctly and you just somehow got the wrong answer, I'd give you half a point. Okay, so the dot product. Everybody figure out the dot product, please. Dot product. You guys need to be bringing your calculators to class. Seems you're being allowed to use them more now. Bring your phone, your iPad to class. You can bring your calculator to class. What'd you get for the dot product?
I did it wrong. Is it? I got
That's the dot product. Okay, the magnitude of u would be the square root. Magnitude of v. That's how you do the magnitudes again. There isn't anything new that we're doing today. Just adding another coordinate. Oh, and for your information, 4 squared is 16, not 4. For those of you who put that easy calculation yesterday. There are a lot of just miscalculations. And as we get chapter 10, when we get to chapter 10, there is a ton of calculations, multiplication and addition calculations, on every problem. Matrices, manipulating matrices. Lots of room for errors. You guys stop talking. Lots of room for errors in chapter 10, and you can't mess that up. You have to be perfect on that. So telling me 4 squared is 4 is going to ruin all the work you do in chapter 10. We need to make sure we get this right. So this is 16 and 4, that's 20. So that's the square root of 20 for u. 4, is that right? 2 squared. Oh, sorry. Negative 1 squared is 1, so this is going to be the radical 5. So this is what you're going to get for the cosine of theta, but we need to simplify this. The square root of 20 is 4 times 5, or 2 radical 5, times another radical 5. And anytime that you multiply two of the same radicals together, radical 5 times radical 5 is radical 25, which is 5. Just the number there. So 2 times 5, that's going to be 10. So we have 8 tenths, and that reduces to 4 fifths. So the cosine of theta equals 4 fifths. Now use your handy dandy calculator. Tell me how you're going to figure out what that degree is. How do you do that? How do you do it? I just want to know how to do it. What are you doing on your calculator?
Or cosine.
Yeah. So the inverse of 4 fifths. The arc cosine of 4 fifths is what? 36.9 degrees. So that's the degree between the two vectors. Can we get 36.9? Okay, and one last thing I'm going to show. Well, maybe two things. Direction angle. Anybody know what a direction angle is? That was in the last few sections. Direction angle. Direction angle is the angle from the axis to your point that you're talking about. So if I give this number 38, you should have this in your reference sheets, but if you don't, that's okay. We have I minus 2j minus k. Alright, so what's our vector?
1, -2, -1.
Yeah. 1, -2, -1. You don't need to write the vector, but just make sure you understand what it is. Finding direction angles is this. The cosine of alpha, that's alpha, equals the first entry over the magnitude of that vector. So we'll just do this and I'll show you the other two things that we need. So alpha is just like theta, it's just another, you're just talking about a different degree here. So A1 is what? A sub 1 is what? Yeah, the first entry. So 1 over, what's the magnitude of this vector? Everybody figure out the magnitude. Thank you. So the cosine of alpha, weird shape, equals 1 over radical 6. So what's that degree? You do the same thing you did down there, you take the arc cosine. So the cosine, arc cosine of 1 over radical 6 equals your alpha, which is what? What'd you get? Do you know what you get? 60? 66 degrees? Around 66 degrees? Okay. So basically what that's saying is from the x-axis to this point that it's referencing, this is a direction angle of 66 degrees. I need to know the cosine of Bravo. I need to know the cosine of gamma. Alpha, Bravo, gamma. But it's not Charlie, it's gamma. Alright, so this one is just the second entry, again, over the magnitude of A, which you've already figured out. This one is the third entry over the magnitude of A. So these things you should have on your reference sheet somewhere. We didn't really go over them too much in the earlier sections, but now we want to make sure we hit them. And then when we talk about the graphing, you should be able to see those degrees coming out. So I'm not going to do these. You do these the same way you did this. Okay? That's how you find the direction angle. Okay. Page 608, 3 to 43 odds.